Yes. So today we are discussing a question, a very nice, interesting question. So let us look at the question first. Read the question. It says that a wet umbrella is held upright as shown in the figure. The man holding it is rotating it with about its vertical shaft at an angular speed of 5 radians per second. The rim of the umbrella has a radius of zero point 0.5 meters and it is at a height of 1.8 meters from the floor. The man holding the umbrella gradually increases the angular speed to make it 2 omega. Okay, calculate the area of the floor that will get wet due to the water drop spin of the rim and hitting the floor. They have given the g value as 10 meter per second square. So the question is pretty simple to understand, so I hope you understood that there is a umbrella, there are some water on this umbrella, and when the man holding the umbrella about the handle, if he starts rotating it with an omega angular velocity, because of the rotation the water droplets will start coming out of the umbrella like this. The water droplets would be coming off, and because of the rotation the water drops would be coming out with some velocity, and because of that it will not exactly fall down vertically, it will cover some distance and it will fall. Now the man is actually increasing the speed of omega. It is increased from omega to 2 omega. So while doing this, he's doing this in a gradual increase process. So he's starting from 5 radians per second and then slowly increasing it to 10 radians per second. During this the water would be falling on the ground in a particular area. So they're asking how much of this area is covered by the water, what is the wetting area of the water on the ground. So this question is kind of, we can say, completely based on projectile motion, because the moment the drop falls off from the or leaves from the umbrella, after that it is going to completely be determined, how it moves will be determined by gravity. So that is called as actually projectile motion. So first of all, because of this rotation, let us find out how much velocity the this, what you can say, the particle, that is a water droplet, will achieve. So let me also draw a circular shape diagram here. This represents the umbrella shape from the top. So when you look at the umbrella from the top as an observer, what you see is a circle, this being the center of the umbrella, and these are the locations from where the water droplets are actually coming off, right? That's the end of the umbrella. And how much is the radius they have given for this circle? See, look at that. The radius of that circle they have given is 0.5 meters. Okay, so you know the radius, you also know the omega. That omega value is given as a 5 radians per second. So by using omega and the radius, can I find out the velocity of that? So I can find the velocity v is equals to omega into r. Omega is nothing but 5, radius is nothing but 0.5, so I'm getting it as 0.25 radians per second. This is the velocity of all the particles, that is the water droplets at the end of the umbrella, that is v. Like this it will look like. I hope you understand. Tangentially these velocities would be, right? Okay, same velocity if I have to show here, let us say for one particle, I can say that this particle would be having this velocity in this direction, the second particle would be having like this, the third particle would be having like this. I hope you understand all the droplets which are coming off the umbrella is now having a horizontal component of velocity which is equals to 0.25 radians per second. Vertically there is no velocity, it starts with zero velocity, but gravity will keep pulling it down, and because of that this will be now covering some distance like this. Okay, so I hope you understand. Like that, all the particles, all the water droplets would be covering some distance because of the horizontal velocity around that umbrella. Okay, now after increasing the velocity from omega to omega dash, that is 2 times omega, then the velocity also becomes from v to v dash, that is omega dash into r. That omega dash is 2 times of omega, so that is basically 10 into radius is 0.5, and this gives me now 5 radian per second. Oh, sorry, velocity I'm calculating, then how can I put it in radians per second, right? So both of these are actually meter per second. Okay, so I can write this as meter per second and this also meter per second. Fine. So now can I say safely using projectile concept that it is this velocity which will be used to cover horizontal distance by the drop, because this is nothing but horizontal velocity, and vertical velocity is 0 initially, but height is given for how much height it has to fall, 1.8 meters. So using that height and initial velocity being 0, can I find out the time taken by the drop to reach the ground? The time can be found by using s is equals to ut plus half at square concept. Initially vertical velocity is anyway 0, vertically the acceleration is g, that is 10 they have given in the question. Displacement is 1.8, half into 10 equals to, we get it as, sorry, into t square. So from here I can find the time as this will become 3.6 divided by 10, so I'm getting basically 36 by 100 root 2, so which will come out to be 6 by 10, so 0.6 seconds. So the drop would be reaching the ground in 0.6 seconds. During the 0.6 seconds when it is falling, it is also covering a horizontal distance. So question is, how much horizontal distance is this drop covering for both the cases? First case when the velocity was only omega, angular velocity, and second case when the angular velocity became 2 omega. Now if you think here, what will happen when you start rotating this umbrella, and when the drops start falling, it will fall on the ground in the shape of a circle. In the first case, it will be falling off at a radius r, and in the second case, it will be falling at a bigger radius of r dash. Please think about this. So where would you be finding the water droplets? Means this is the region where you can expect to find the water droplets to land on the ground, right? This is the region where it will become wet. Now what is this capital R and r dash means? It's nothing but the capital R is a projectile radius, as a range of that projectile for the first case when the speed was omega, and r dash is the range for the second case when it became 2 omega. So now we can find out the range for both cases, right? So range formula would be what? Range r is equals to, we can use either directly the range formula we can use, or actually it is much more easier here because time I know, horizontal velocity I know, so why to use a formula? I can find the range in this way, that r is equals to horizontal velocity into the time taken, the t to fall. So I can say horizontal velocity is nothing but 0.25, and the time taken for the journey is 0.6 seconds. So into 0.6 seconds. So this will come out to be how much? 6, 5, 30, and then 12 plus 3, 1.5. So I think I'm getting 0.15 meters. Let me just check that. So answer for this part is yes, I'm getting it as 1.5 meters. Okay. So why is that? Yeah, I made a mistake here. See, 5 into 0.5 is actually 2.5. Sorry about that. So this is 2.5. So if this is 2.5, then my answer would be 1.5. Okay, 1.5 meters. And what about this second velocity, this case? So I'll be getting an r dash here, which will has v dash, into t. Time is same for both cases, right? Because the vertical component, there is no change. So obviously the time will remain same. So v dash is equals to, now 5 into the time again is 0.6. So 6, 5, 30. So this will become 3 meters. So I'm having two ranges. I have that. Now I have to only find out the area. That's the easy part. So area is equals to pi into, we can say, r dash square minus r square. Bigger area minus smaller area. So pi into r dash is nothing but 3 square minus 1.5 square. All right. So this would give me pi into 3 plus 1.5 and 3 minus 1.5 using the concept of a square minus b square. So pi into 4.5 into 1.5. So this multiplication would give me how much? That gives me actually 21.2. Answer comes 21.2 meters square. So I hope all of you have understood this concept. It's a very practical question, and actually it's a simple question. So I won't categorize this as a difficult one. But at the same time, the person or the student aspirant has to have a decent amount of imagination to understand what is happening. You have to realize it's a projectile motion question actually, because after leaving the umbrella, the water droplet would be falling according to gravity. So obviously it will follow the projectile rules. Okay, so that's it. I hope all of you have understood this. Any doubts you are having, make sure to comment. Okay.